Well, hello and welcome to Doc Onco Physics. Keith Onco here. Today what we want to do is we want to take a look at one of the tools that we use all through physics courses, and that is basic trigonometry. Now, we don't really need to use advanced trig in the beginning physics courses, but it is critical that we are able to use and understand the basic trigonometry functions, and there's really only three that we use, in order to solve a whole variety of different problems. Because many of the problems that we solve in physics, or we deal with in physics, have to do with vectors, okay? And oftentimes we want to break vectors down into component parts. And that's what basic trig allows us to do. And so what I've drawn here is I've drawn a right triangle over on the right-hand side over here. And I've labeled the sides A, B, and C, much the way you might label them if you were using the Pythagorean theorem. A squared plus B squared equals C squared. I have also labeled two of the angles in here. The top angle up here is theta 1, and the angle down to the lower right-hand side is theta 2. And the angle on the lower left-hand side is a 90-degree angle, so I've just put in a little square down in the lower left-hand corner. Okay, and let me slide back up here a little bit. What basic trig allows us to do, and I'm just going to read this, the basic understanding is that if I have a right triangle, and that's a triangle where one of the angles is 90 degrees, okay, and that's critical, has to be that. If two things are known about the triangle, then using trig functions, more information can be determined, or basically we can determine everything else about that triangle. We can determine all of the lengths of all three sides. We can determine all of the angles of the triangle. So we just need to know two things, and we can figure everything else out. All right? These two things can either be one of the angles, right, in addition to the 90 degrees, and the length of one side, or the length of two sides. If we know the length of two sides, we can get everything else. Or if we have one of the other angles, either theta 1 or theta 2, right, and one of the lengths of the sides, then we can get all of the other information about the triangle. Now, note that if I just know what all three angles are in the triangle, right, if I know the 90 degrees, right, over here, right, I know theta 1 and I know theta 2, well, that's nice. I know the angles of the triangle, okay, but if I don't know any of the sides, right, then I can't get any of the other sides, okay? So the two things that I have to know are either two of the lengths of the sides, all right, two lengths, or one angle and one length. Over on the left-hand side, what I've done is, whoops, didn't mean to draw a line there. Yeah, what I meant to do is just sort of circle it over here. What I've drawn in are the three trigonometry functions that we're going to use, okay? And the functions are the sine, the cosine, and something called the tangent. You don't have to worry about the names of them. They're rather meaningless, okay? What each one of these operators or functions has, all right, is associated with three variables. The first variable is the angle that we're interested in, okay? The second variable is the length of the side, for the sine function in this case. The length of the side, in this case, that is opposite to the angle. Well, what do I mean by that? Well, let's say that angle theta 1 is the one that I was interested in. Okay. Well, what's the opposite side to theta 1? Well, it's not A. A is an adjacent side. All right. C is the hypotenuse and also is an adjacent side. All right. What's the only side that is opposite? All right. It would be side B. Okay. So in this case, the sine of theta 1, right, because that's the angle I said I was interested in, is equal to the opposite side, that would be B, divided by the hypotenuse. Well, in our case, the hypotenuse is C. So if I knew two of the three things, say I knew the value of theta 1 and I knew the value of c, I could simply plug them in and solve for b. Okay, and it would really be that easy. Okay, now how do we do that? Well, let's slide down here just a little bit more. Right, we do that using our calculator. Okay, this is a very basic TI-30X calculator. Costs about $10. You don't need an expensive calculator for this course. This is really all you really need, and I strongly advise this type of calculator because history shows it's been the easiest one for students to use. The functions for sine, cosine, and tangent are right sort of in the middle of the calculator, and I've circled it in red over there, okay? So that if I want to know what the sine of an angle is, right, I simply hit the sine button on my calculator and type in an angle, and I'm going to get some number, okay? So let's say the sine was 30 degrees. So I would hit the sine button, and then I would type into 30, and I would hit enter. Now if I did that, what the calculator would come up with is 0.5, because that's what the sine of 30 degrees is equal to numerically, okay? And so in my case, 0.5 would be equal to b divided by c. Well, if I knew what side b was equal to, let's say b is equal to 10, all right? So b is equal to 10. I could easily figure out what my hypotenuse is, all right? It would simply be 0.5 is equal to 10 divided by c, which is my hypotenuse, okay? And so c is equal to 10 divided by 0.5, and c is equal to 20, whatever those units are. I didn't say whether they were meters or centimeters or whatever, okay? But that's how we use trigonometry. It's basically just some functions on the calculator, okay? Well, so the sine is great. Sine of the angle is great if I'm interested in the opposite over the hypotenuse. So opposite side and the hypotenuse, right? Well, what if instead I've been given the adjacent side and I'm interested in the hypotenuse, right? So here's my angle again. Theta 1 is my angle, right? And now I've been given the adjacent side. I want to know what the hypotenuse is again. Well, again, let's say that our angle in this case is 45 degrees. So that's angle. So theta 1 is equal to 45 degrees. Okay. My adjacent side A, let's say that adjacent side in this case is going to equal to 7 centimeters. And I would like to know what the hypotenuse is. Okay. Well, again, all we're going to do is plug these things in. So I'd say the cosine of 45 degrees is equal to the adjacent side, which in this case is A. A is adjacent to the angle, right? And so that's going to be 7 centimeters, divided by C, which is my hypotenuse. And this enables me to figure out what C is. Well, the cosine of 45 degrees happens to be 0.707. And this is going to be equal to 7 centimeters divided by C, right? And so if I divide 7 centimeters by 0.707, 7 divided by 0.707, I get 9.9 centimeters. So C in this case would be equal to 9.9 centimeters. Okay. Well, again, what if in the third case we are given, say, the opposite side and we're interested in finding the adjacent side? Well, in that case, we use the function called the tangent on our calculator, right? Just another function, right? So again, we need to know the angle, right? And depending on what we're looking for, either the opposite side or the adjacent side, we would simply plug in the numbers, and that's how we use these three functions. Okay, so it's fairly basic. However, it's critical that you be able to do this work, because if you're not, right, if you're not able to use these functions on your calculator, physics becomes very difficult. Okay, so let's slide down here and let's do some examples. Okay, so the triangle on the right has an angle of 18 degrees over here, right? And we know that this side is 100 meters, and we'd like to know the value of h over here. All right, so we have a right triangle. You see that? All right, so we can validly use the three basic trig functions. And so this 100 meters, this side over here, we need to figure out is what? Is that the adjacent side, the opposite side of the hypotenuse? Well, this is the hypotenuse up here, right? So it's not the hypotenuse, right? The opposite side to this 18-degree angle over here would be h. So this is the opposite side. And so this 100 meters here is the adjacent side. Okay, so we have the angle, we have the adjacent, we're looking for the opposite. Which function would I use? Well, if I take a look at sine, well, sine certainly has the angle. It's got the opposite, so that's okay, but it deals with hypotenuse, so that's not going to help us. Cosine has the angle, adjacent side, which we have, again, the hypotenuse. Okay, that's not going to help us. How about the tangent? Well, the tan function will help us, all right? It's got the angle, and the two other variables are the opposite side. Well, that's what we're interested in. And the adjacent side, that's what we know. So that sounds good. So let's see. So if I wrote this down, the tangent of 18 degrees is equal to, right, opposite over adjacent. So it's going to be h divided by the adjacent side, which would be 100 meters. Okay. One really important thing, and most of the calculators come this way, is there's two ways to put an angle into your calculator. You can do it in radians or degrees. Make sure that your calculator is in degree mode. If you look up in the upper side of your screen, actually, it's in the lower part of your screen, it'll tell you either radians or degrees. It should say DEG right underneath whatever number you have. Okay, so I'm going to type in the tangent, hit the tangent button, and put in 18, and I come up with 0.3249. So 0.3249 is equal to h divided by 100 meters. So if I want to know h, I just cross multiply here. So times 100, and h is going to be 32.49 meters. So that will be the height of my triangle on the right-hand side, right? Simply using these sine, cosine, or tangent functions. Okay, so let's try one more example. And in this case, it's a little bit different. We know the hypotenuse, okay? It's a right triangle, we can see that there. But the angle that they've given us in this problem is 60 degrees, but it's in the upper right-hand corner, okay? And that's perfectly valid, doesn't make any difference. You just have to be careful about what your adjacent side is and what your opposite side is in this case. Looks like we're looking for, again, we want to know what the height of that vertical component of our triangle is. This is definitely the hypotenuse, all right? So this is our hypotenuse. The question is, what is this vertical component over here? Is it the opposite side? Well, the opposite side to our 60-degree angle would be this. This would be opposite, okay? This x centimeters here, this is the adjacent side to this 60-degree angle. So, adjacent. All right, so we have the angle, the hypotenuse, and we're interested in the adjacent side. Which function will give us what we want to know? Well, let's look at the sine function. The sine has to do with the angle opposite in hypotenuse. Well, that's not what we have. Cosine has to do with the angle adjacent in hypotenuse. This one looks like a winner. Tangent has to do with opposite and adjacent. Well, we don't know the opposite side. right? So this one's not going to help us, and this one's not going to help us. So it's going to be the cosine function, okay? So I'm going to say that the cosine of 60 degrees is going to equal what? The adjacent side, right, x centimeters, divided by the hypotenuse, which is 13 centimeters. Okay, so let's first plug in to my calculator the cosine of 60 degrees, and that should be 0.5, and it is. Okay, so 0.5 is equal to x centimeters divided by 13 centimeters. And again, if I just cross multiply here, 0.5 times 13 is 6.5. So x happens to be 6.5 centimeters. And that would be the vertical height of my triangle. And that's really all there is to using trig functions. And these are the very basic trig functions. And there are many others that get more complex. But all we really need to know for a basic physics course is how to use the basic trig functions. Okay, so let's try one more example. Okay, and in this example, we don't know the angle, but we do know that side over there, and we do know the hypotenuse. So we have the hypotenuse, okay, and the question is the 7 over here, is that the adjacent side or the opposite side? Well, my angle is over here, okay, so the adjacent side would be that, and this is then the opposite side. So I'll have my hypotenuse, the opposite side, and I'm looking for the angle. Which one of these trig functions is going to help? Well, the sine has to do with the angle. It's got to do with the opposite side and the hypotenuse. So this looks like a winner right away. Okay, so let's plug in the numbers. So the sine of x is going to equal the opposite side, 7, divided by 25, and we haven't been given any units. All right, 7 divided by 25 is 0.28. Okay, so the sine of x is equal to 0.28. All right, well, up to this point, when I have typed in numbers using the sine, cosine, and tangent functions, I typed in sine, right? I hit the button, the sine button, if you will, and then I hit the angle. Well, I don't know the angle. Okay, so this is where what we need to do is we need to use an inverse function, and it's called the inverse sine function. So if I were to do this to both sides, sine to the minus 1 times sine, right, is equal to sine to the minus 1 of 0.28. Okay, so I've got this is now equal to this. So, and all I did was multiplied each side by sine to the minus 1. Okay, and all sine to the minus 1 is 1 over sine. Okay, so what have I got on the left-hand side over here? I've got sine divided by sine, right? And that cancels those out. Okay, and so what I'm left with is x is equal to sine to the minus 1 of 0.28. Well, if you look on your calculator, I'm going to scroll all the way back up here. If you look on your calculator, and unfortunately I have taken my calculator and I've got my sine and cosine tangent buttons, and I drew my red circle around here. But notice above every one of these functions on our calculator, there is a second function that we can use. Right above the sine is the inverse sine. Right above the cosine is the inverse cosine. Right above the tangent is the inverse tangent. So if I want to use those functions, I simply hit the second button, right? And then whatever one of these functions above the button I want to use, I just hit that. So in the case where I need my third example down here, I need the inverse sine. Well, I'm going to hit the second button, all right? And then I'm going to hit the sine button, all right? So I get my inverse sine, all right? And then I'm going to type in 0.28, and that's going to give me the angle x, which is what I'm looking for. So let me do that on my calculator. And I get an angle of 16.26 degrees for x. So x is 16.26 degrees. Whoops, that's the dot there. And that's what x is. Okay, so you will need to be able to use the inverse sines as well, the inverse functions as well as the normal functions. Okay, the more you do these, the easier it becomes. Okay, so sine, cosine, and tangent, inverse sine, inverse cosine, inverse tangent, depending on what you're looking for. If you need to find the angle, okay, and you're given the sides, you need to use an inverse function. Okay, if you have the angle, okay, then you could just use the normal function. Right? I hope that helps. All right, it seems to me the last example that I was going to do. I hope that helps, and have a great day.